Parallax Robotics Team 18386 Introduction to CAD series. So in this series, we're going to be covering the basics of CAD and continue to teach you guys new features of OnShape. But before we get started, we're going to introduce our team and some aspects of CAD. So a little bit about our team. So as you can see, this is our team. We currently have 12 to 14 active members. And this is our third year as a FTC team, which is First Tech Challenge. And we have 5 rookies on our team, which is 5 people who are new to the first program. We are based in Mason, Ohio, and affiliated with our local high school. Here are some photos that highlight our season. So this is what our robot looked like for one of our previous qualifiers. And here is another angle. And so as you can see, we used to have a paper print of our number, but we got it cut. And we have an outreach robot, which we call a dogoid, and we use this to demonstrate with little kids when we go to in-person demonstrations. This is a photo of our pit, and we decorated it to our team colors and to display how we value gracious professionalism as well as spreading outreach throughout our community. But what is the first program? So the first program has 4 different levels, which is First LEGO League Junior, First LEGO League, First Tech Challenge, and First Robotics Competition. We are part of First Tech Challenge, and we have people on our team all the way from grade 7 to 12. So we encompass a variety of different age groups. But the difference in each of them is that First LEGO League Junior and First LEGO League use robots made out of Legos and block coding. First Tech Challenge uses physical robots made out of things like metal and plastic with Java or different types of coding that allow it to run on the field. And then for First Robotics Competition, this is more focused on high school, and the special playing field has robots that are huge. In all of these aspects, the primary values that First places an emphasis on are outreach, gracious professionalism, as well as the value of healthy competition. So we utilize something called the engineering design process to begin our season, which starts out with strategizing, brainstorming, prototyping, 3D modeling, programming, and actual creation. And by using the engineering design process, we're able to have a successful season with a structured plan. So that's where CAD comes into play. But what is CAD? CAD stands for Computer-Aided Design, and it's used for creating online models, essentially converting a 2D figure to a 3D shape. But with these 3D shapes, we can use them to design for 3D printing and manufacturing as well. This can be used in fields like engineering, healthcare, analytics, manufacturing, and even technology. The purpose of CAD is to optimize the physical design process, and there are many different softwares for CAD, things like SolidWorks, AutoCAD, Tinkercad, Blender, Inventor, and OnShape. And here are some logos. We're going to be teaching you guys how to use OnShape in this series. And the purpose of OnShape, especially within working in a team, is so that you can collaborate live and watch what other people are doing in a strategic scenario. So CAD in engineering helps us optimize the design process and workflow. And this is an example of what a CAD model could look like on the screen. But it's used primarily to design prototypes, parts, and products. Within the engineering industry, you can find this in chemical, civil, electrical, mechanical, or even structural analysis. In Parallax, we use CAD for a lot of things, but it begins in different phases. In phase 1, which is essentially putting together individual parts or motors or different mechanisms, it might look something like this. It's more vague and individual, it might be independent, and when we consolidate it, could look more like an actual robot. With phase 2, that's where we kind of assemble all our parts on OnShape using the part assembly feature, which we will get to later in the series. But that involves us putting our actual mechanisms and parts all compiled in one file. And so we have things like beams, motors, gears, axles, and we use things like Tetrix and GoBuilda on our online software. We can also design our own individual parts. So these things in light blue are actually designed by us and aren't from the downloaded software online. Phase 3 comes when we print our actual parts and assemble what's on the CAD file. So this is an example of what we assemble called our odometers, and these green parts were 3D printed. In this, the metal parts were cut by a company, and that is what we designed in this phase over here, where we have our light blue features. So in our engineering design process, after the prototyping comes the 3D modeling. So we'll actually take our prototype, whether that's made out of cardboard or plastic, and convert it into a 3D model by using OnShape. We'll brainstorm any designs, test our theoretical physics concept, use spatial awareness and logistical planning to ensure that our robot is kind of made in the way that we want it to. And after that comes programming, where we program our bot to run on the field. The timeline of CAD begins with sketching, and as it said on the slide, the first step to any robot build is to sketch. It's important because if you go straight to CADing the robot, you have no idea what it's going to look like. So we'll make physical designs, whether that's on paper or on a dry erase board. Sometimes we'll even take it to the next level and make a cardboard model, and then we can go to OnShape. And so we'll use this to CAD our sketch into life, and so we'll bring the motors, the hub, and all the other parts needed for assembly and make our own features where they're necessary. And lastly, we'll go ahead and get our parts printed or cut and test the design. So we'll fully assemble our robot with the necessary pieces to see if the robot functions how it's supposed to be programmed with the controller. And it should look something very similar to the CAD model, but a part of this process is learning how to adapt when the features on OnShape don't match our physical design. Now we're going to go through some basic CAD softwares. So as we mentioned, we like to use OnShape because it's good for team integration, but there's things like Autodesk Fusion, which allow us to design products to ensure aesthetics, form, fit, and function. And so some other functions of CAD on different softwares are comprehensive electronics, PCB design tools. As you can see, we can also use CAD, CAM, CAE, and other things on Fusion 360 to unify our design process and electronics. It has data management and cloud collaboration, and the photorealistic rendering and documentation allow us to make for a realistic and lifelike design. So these parts look more like a 3D model than they would, but a great basic way to start is by using Tinkercad, which you might even have used in school. Once we kind of orient ourselves with the basics of CAD, we move on to these more advanced softwares. In addition, there's things like Autodesk and AutoCAD, which are both based on Autodesk, and so these are both from the same company, which is Autodesk, but Fusion 360 and AutoCAD have different principles and methods. So Fusion 360 is used for 3D modeling and manufacturing, while AutoCAD is primarily used for 2D modeling to switch to 3D with drafts. But OnShape is what we've been using for 3 years because it's highly accessible, browser-based, user-friendly. It even has a phone-based function. It's used across many industries, and it has a part assembly organization which allows us to make 4 individual components to put together in an easy-to-share file for collaboration. And that's essentially the goal of our CAD camp, so we're going to be going through some basic outlines today. But the objectives of our CAD is to first start off with an introduction to understand how to navigate OnShape. Then we're going to learn how to use sketches, including 2D to 3D figures, which will be an extrusion. Then we're going to learn different features like fillet, revolve, etc., and move on to part assembly, which, as we mentioned, allows us to create individual components in a larger project. And then you're going to be using your CAD skills to make a new design, which could be something of your choice or by an inspired prompt. So then we're going to go to the intro. Go ahead and click on the next video of this series to begin orienting yourself with OnShape.